step one, we'll pick up now with libraries. So we've seen a bunch of different libraries in the course. We're only the standard library, which is the first library that we ever saw. It has printf in it, among a bunch of other functions. We've also used the math library. Some of you maybe after step one, if you like to round a floating point value in your strings. And then we also have the CS50 library that we gave, which is really useful for getting types of input from the user. So you might remember that in order to use a library, we typically need to include one or more header files. So something like having included CS50.h. And then you go to compiler code, in order to actually implement the library, we need to include this -l CS50 file or -l, whatever the name of the library is. So if it's math, then we'll use -l lamp. If it's a standard library, then we don't include that at all because GCC just kind of assumes that we want to implement that, even if we don't say so. Any questions about libraries? Cool. So functions. So we've seen a bunch of functions too over time. The first one that we ever saw was this function called main. It's really important because main is the first function that runs whenever you start running a program. So compile your code, go run out the command line. This function is the very first thing that's going to run. So we see some stuff that's kind of familiar. We see int, main, and the void in here. We've seen you can do other stuff other than the void, but we'll talk about that in a sec. And here this opening curly braces, exposing it at the end. In between is basically just the body of our function. So our main function here, we're going to do something, whatever. At the very end, we have this convention where we return 0 from main if everything is okay. If we encounter some sort of error, some sort of problem, then we'll return some other value that's not 0 to indicate that there was a problem. So more generally, any function can have a return type, which is the type of the thing that you're going to return. So again, main returns an integer by convention. Your own function can return any other type that you can think of, where you do nothing at all, so return in that case which is void. And then the name of the function, in between these parentheses, we specify any of the arguments that the function is going to take. So the first thing we have to say is the argument type. So if it's an int, it's a char, if it's a char star, or something like that. And then the name. The name is just like any of the variable. It's how we're going to refer to whatever argument value we get from whatever clauses. This just means we can include 0 or more arguments in the functions. Likewise, between the curly braces, we have the body of our function, and then at the end, as long as it's not a void function, then we want to return some sort of value for it. So just in terms of how functions work, if you're kind of confused about this, it maps kind of nicely to math. So if you think back to like high school math or something like that, we have this function here, f of x equals x squared plus 4x. And if you want to find out what like f of 2 is, it's really simple. Just plug in 2 in place of x, and then do that on both sides, and you see that f of 2 is 2 squared plus 4 times 2, and that ends up being 12. So really similar concept here. Here, in this case, x is kind of like our input, except this function takes one parameter, some sort of number, we call it x. We're going to return basically this value of x squared plus 4x. So the return value in this case of that 2 is 12. If we want to see the equivalent in C, then we've got this function in again. We're going to say it returns an integer, and we say it takes an integer. It could be a float or a double if we want, but for this, we would say it's going to be an int. Call the function 2 instead of f, just the decision I made. And then we return x times x, or x squared plus 4x. These are equal to this math function. Any questions on this function stuff? Yeah.
So why is it advantageous to have a return in this case? Why is it advantageous to return that value instead of
Okay, so why do we return the value instead of like using like printf or something like that? So returning stuff can be useful in a lot of cases. Sometimes we might want to have some bit of code that we want to execute multiple times. Like there's some functionality that we want in multiple parts of the program. And rather than writing out this equation every single time, if I just want to calculate it and then need to use that number for some other purpose other than actually explain it to the user, we want to return it so that our program can take that value and do whatever it will with it. So maybe this value, it's not something we want to show the user, it's just something we want to use to calculate something else maybe, or whatever we're going to do depending on what the function does. It may be that we just don't want to show it to the user. So,
how do you access that value?
How would I access the value? So, I'll take a look at an example that might kind of help with that. Basically, you can take whatever this return type is, you can assign it to a variable. But I'll show you that in a second. Any other questions? Yeah.
Could you add
Yeah, so the question is, if you had this function in your code, could you do something like printf for example. We had to take that numeric value that was actually a string and then convert it to like an int or some other numeric value that you could use for math and stuff like that. So look at this example. If I run a program called program name and I give it CMD line args, so what's arg CMD? 4, right? Because at 3 you were close, but it's going to be 4 because it's 1, 2, 3, 4. It's the number of command line arguments. It's got nothing to do with indexing 0, it's hard to see. But where 3 does come into play is when we try to access the different command line arguments. So argc is 4, that tells us there's 4 different values in argc. We start at an array of 0, so it's 0, 1, 2, and 3. And these arguments are just going to be in order of what you see up here. So program name is always going to be the first command line, then CMD line args for the next 3. Any questions on command line args?
Why is it that you only need to check if something's null if there's only one RT equal to 1?
Why do you need to check if something is null if argc is equal to 1?
If RT is equal to 2, then you have to check whether RT is 0 or rather.
I'm not sure that I understand the question. Ask us later. Okay, so now a little bit about scope. So we saw this function that created called swap that is supposed to swap 2 different integer values. As the comment kind of implies, it doesn't actually do that. The reason for that is scope. So basically, whenever you pass something like an int to a function, we do this thing called passing by value. And what that means is if I'm a caller and I call this function called swap in my code, I'm actually going to pass it, the actual variables that I'm dealing with. I'm not passing it, the memory addresses or anything like that of A and B. In this case, I'm just going to pass it a copy of the value A and a copy of the value B. So if I call swap on like 5 and 10 are the variables that have the values 5 and 10, swap is just going to get those values. They're going to get copies of those values, but it's not going to have any way of referring to the actual variables or the sort of those things. So we're going to have this int A, this int B, and this int temp, and these are all going to be local variables in the context of swap. And when this swap function goes away, we're not going to have access to any of those things. The solution we saw to this problem was to introduce this notion of passing by reference instead, where instead of giving swap the actual values that I want to swap, we're going to give it the memory addresses where those values are located in memory. So we do that by giving pointers, so we can store A, we can store B. We'll talk a little more about pointers later on in the review session. Basically, the idea is swap now has access to these memory addresses, and by virtue of having access to the memory addresses, it now also can go see what these values are. And it can use these memory addresses to take the value A, and then use value 5, put that in this local variable temp. We'll dereference this memory address again to put the value of B, so say 10 if that was their value. And we'll put the value 10 into this place where 5 was previously located. And then it can place the old value of A that we got over here, and put that into the location of B. This will actually get that swap effect that we want. Next, a little bit about training, which is going a little bit deeper into how memory works in C. This will also hopefully show you how to deal with return values and functions. So we have 3 simple functions here. Sorry, it's a little small, but we have one function main down here. There's another function foo and another function bar. Foo and bar both return integer values and they take integers as their arguments. So if we start off in main, we have this line int x equals 5. Now here I've just indicated 4 bytes in main. This whole thing is sort of the stack, so it's part of the computer's memory. And we start off with main on the bottom of the stack because, like I said before, we use the first function that runs when you start the program. So just showing you 4 bytes here, they start off as question marks, so if you don't know it's there until you actually initialize it. So we say x equals 5, and that becomes 5. Then on the next line, we say x equals foo of x. So foo, I said, is going to return an int, and x is of type int. So we can say something like x, which is of the right type, and take integer value. So int, this returns an int, so that's good. And we can say it equals foo of x. So whatever foo of x eventually returns is going to end up in variable x right there. So we execute this, we call foo of x. We put foo is the next function we call, so main kind of like pauses its execution. We move over to foo, which goes on the stack on top of main. Foo has this local variable n because it's declared as an argument that it takes. And foo, we said, returns bar of n times 2. Okay, so like I said before, we're going to copy the value 5 over to here so that foo can access the value 5 in its local variable n. And then this call is bar, so this is going to take its local variable I, going to return I plus 1. So I plus 1 is obviously 6. So bar updates that, and then it returns over here to foo. So we've got bar, then you've executed that part, and then we've got to multiply by 2, because that's what the phone line says. So we multiply by 2, we now have n equals 12, and now we've got to return this whole value to main, and we do that so that 12 ends up here as we expect. Any questions on any of that? Cool. So one last bit about memory. So we've seen this picture before. This stack area was where we were just looking in the last few slides. Again, we move again the bottom of the stack, followed by any functions that we call, any functions that call, and so on and so forth, kind of build up on top of the stack. It's like a stack of trays or something like that. We also have this section of top memory called text. This is where the zeros and ones that make up your program actually reside. The instructions that go to the CPU all in the text segment. Initialized data, uninitialized data, both use for these things called global variables. These are variables we declare outside the scope of any function. So if you want to have a variable like g in the Sudoku problem set, this is where you'd be looking up in these two sections, depending on if it's initialized or uninitialized, if there's self-explanatory right there. But global variables would be something you can also any function, there's this thing called global scope. We have this thing called a heap too, where you remember malloc from previous weeks. We'll talk about that in more depth later. But the heap is where we get all of that memory, where malloc is actually going to go to allocate memory. And then this moves down just the way assuming this stack comes up. And then we have this other thing called environment variables. Not such a big deal, but just know that they're there. Any questions on anything